Hello. So my name is Edgars and I'm a QA engineer. I'm a QA engineer at TestDevLab for almost 5 years at the moment, and I have worked for several different projects abroad from Latvia and in some here. And my experience is on setting up testing process for projects as a test consultant and also as a team member. And yeah, I have set up a testing process for projects basically from scratch. When I started to work for them, they have basically one Excel sheet which described some basic manual tests that they have to do before releases. And yeah, so I will talk a little bit about that. So the agenda. I will talk a little bit about the quality issues that I have seen for the projects that I have worked on. Also, what exactly the testing mean in the Agile and DevOps life cycles, what I have figured out, and also I will show what does it mean the test automation, what should we automate and how much, and maybe something we don't need to automate. Also, I will show the CI process, how we are creating it, including the test pipelines, and also how to use monitors, how to monitor your system or test it after it's in production. Some key problems that I have seen for Agile teams. Like the first one is poor code or build quality. What it means, basically, like after a developer has done his job and provide a new build for tester, I have seen that sometimes like the build is not possible to install on your mobile device, or the feature is not even implemented. So definitely there are some issues with that, with communications or something. Also late feedback about issues, and usually they are caused by long manual regression tests. Like if the manual regression test for tester takes 3 days, then there is a potential risk that some critical issues could be found at the third day, right before the release, and we would like to avoid that. And also there are sometimes communication issues for distributed teams, especially when there is a long, like a big time zone difference, let's say 12-hour difference, where each question to developer and the answer from him takes one full day, and like a bigger discussion could take even more than that if we don't have like a common time to work on. And one more thing is that sometimes there are not automation at all, because you know, if there is some repetitive tasks, we want to automate them to do it to do the things faster. But the other side, I have seen that sometimes the automation even slows down our work, and it can become even more harder. But I will talk about this a bit later. And yeah, testing customer bugs, that's the worst case scenario, when we have to test some bugs that we have left in production, and it obviously will take more money to fix them and put in production the second time. So at first I want to show where exactly the testing fits in our Agile lifecycle, and I want to see what are the opinions, and I basically Googled for Agile lifecycles in software development, and I noticed that there are two most popular models. One model looks like this, when the testing part is like a separate part after development, where basically testers are taking the development outcomes and doing the tasks. But there were one more module, and it looks like this, but the difference is that the testing is not mentioned here at all. So the question, where does testing fit in Agile? And basically, as ISTQB says, which is software testers like a manifest, testing occurs at every But yeah, basically testing occurs at every part. Yeah, here it is. So yeah, we can test every part of our our Agile lifecycle model, and I will go further. And I also looked for what's happening with DevOps lifecycles. I googled like what are the DevOps most popular lifecycles and how the testing role is described there. And I found out also one good simple diagram. It's created by Dan Ashby. You can take a look in his blog post, where he simplified describes most common the DevOps process. But as you can see also here, the testing is not mentioned at the top. So what Dan does, he shows that also in this module the testing takes place in every step. And I will tell you what I mean by that. Basically, our team are included in the testing, and as a tester role, he's not our team is responsible for the quality of the project. Like not only the QA who is testing some development outcomes is responsible for that, but also we can test like our process. How, let's say, we can test how we are releasing our product to production. We can check if the release process is correct, if there could be some improvements in that. Okay. What else? Of course, we can validate our development outcomes. That is usually for QA, and we can monitor our system, which we could rely for testing in production. Like we can also track our logs to debug what's going on with our users, and use some alerts for our system to get alerted when there are some issues. So let's start with building our test pipeline, and of course let's remember the same old test pipeline. I will not go in details and describe why it is the correct way how to create our test pyramid and test levels. There is a lot of books about that, and blog posts and talks and so on. But I want to point out that I have seen that teams are relying on acceptance or end-to-end tests a lot, but they forgot about unit tests and integration test levels. And that's a bad part, because unit tests usually are the ones that we can execute in seconds. Like, starting from the widest test set, unit tests are the one where we can get the fastest feedback about our code, and also we can use integration tests. It depends on the project. It's specific. What does the integration tests mean? I would say in some projects that they could be considered also as API tests. Like before we are running our acceptance tests, we check if our backend works. If the endpoints we are using for acceptance tests, if they are actually working, and we can run our API tests in a couple of minutes. And if there are some issues, we save our resources and time and not executing the acceptance tests. But what about the acceptance tests? Acceptance test automation. Usually we have here that some test managers or team managers will say that we want to go and automate all our manual tests. So we are spending less time on manual testing, but we are automating more and more and more. But there are some downsides for this. Like there are a lot of scenarios and combinations of them. At first, even for the manual tests, we cannot cover all the parts, all the possible parts and everything we have in our app to cover even them manually, so why do we want to try to automate everything? Also, of course, in apps there are some parts changing frequently, and when we have a huge set of automation tests, sometimes it could become very hard to maintain them, and I have seen that automation engineers starting to spend more time on fixing the broken tests than writing new tests. And that's the baddest part I have seen, but yeah. And actually, automation, automated acceptance tests is proof that nothing is broken. It will not find you a new bugs like human can. Human will do extra step and perform additional tests, but what automated acceptance tests will do, it will run the previous written code and prove that your product is working as previously. There is no broken things. So, what could we do to create a good automated acceptance test? At first, we should prioritize and automate the critical business scenarios to see what is really important for our project and what the end users will do with your applications, what buttons they will press and so on. Like if there are some parts that are not used at all, then we should consider if it's worth of spending time and money of automating all the things. Also, we should avoid of configuration in user interface, but instead, if it's possible to set up user data or some things that we should use API or if possible then insert data directly in database, so we don't have in automated acceptance tests like create manually these users and all the data, but yeah, we can do it faster. And of course, the most important thing is keep tests stable. As I mentioned, that it's really easy to go on the other side and starting to fixing your tests all the time than writing new tests. And there are some principles, like in my projects where I'm working on, then we have like, if there is a flaky test in your code, then fix it in 24 hours. If it cannot be done, then remove this broken test. And in that way you can avoid of unstable tests in your pipeline. And of course also execute your tests regularly. It depends on project, how big or small it is, but if you will execute the tests periodically, you will basically monitor them and you can catch even some other parts why it's failing. Like maybe there is Wi-Fi goes down in your office where you have physical test devices and things like that can be caught before some code merges them. And regarding the device, of course, in different projects there is different approach how to use devices. Like for unit tests, there could be a combination of simulators and some cloud devices. And for acceptance tests, what we are doing at TestDevLab, we are creating our own device laboratory with physical devices. And the goal is to run tests under real world conditions. At first, we want to cover the top operating system versions and device manufacturers. Let's say if we are testing Android app, then we will at first take a look at the most used devices for your product, like not the worldwide, but let's take a look what exactly your product on which devices it's installed. At first, we can do some principles like let's cover top 5 devices, and also for regarding operating system versions, we should try to cover all the major versions. Like for Android, it would be like starting from 4.x until the 9 beta that is currently rolled out. And of course, tests have to be executed simultaneously, and that means if we have created automated acceptance tests, then on 20 devices the test will take the same time as it will take on one device. And using Smart Hub is a great thing. It is possible to buy Smart Hubs, which means that you can remotely control your devices by adjusting charging time. You can show how many amperes do you want to charge your devices, and yeah, like using Smart Hubs, you can extend the lifetime of your device's battery, because that's the biggest pain for physical device laboratories, that the battery lifetime is very short, and using Smart Hubs is a good approach. You can build it by your own. Also, we have some blog posts how you can do it by yourself, or you can buy already created Smart Hub that you can use. And the good side of creating your own laboratory is that you don't have any limitation of device usage, and you will not get charged for every test that you will start, and you can do your tests like for 24/7. And for teams where automation is using heavily, like trying to automate all the product in the good way, that's a good part, that you are not charged for every test that you are executing. This is how our device laboratory looks like. Here in Riga we have a physical Android and iOS devices, also some desktop computers where tests are running, and yeah, this is how it looks like in life. Going further, how we are managing the continuous integration part, and starting with the branches. We are trying to test all the branches that developers are creating, and we are using our CI tool. At the moment it's Jenkins, because it's really easy to configure, like to run acceptance tests on Jenkins. And what this means to test branches, like every time when new branch is created in code repository, at the same time it will show up in the CI job. And the repository is not, but the branches are updated with each commit in the CI system. Like every time there will show up new commit in the CI system, the latest code also will show up. And that basically means that devs can test their code before creating a pull request. Like these tests are not triggered automatically when the branch is created. The test is not started automatically, because we don't want to load unnecessarily all our systems. But if the developer has done some work and he says, okay, I could do a pull request, but let's test our system. So he can easily go in Jenkins, select build now, and wait 20 to 30 minutes and see the outcomes if the test will be passed. So he will be sure that, okay, I can do a pull request and merge, and the test will pass. And using build triggers, we are using automatic build triggers for the master and development branch. And it means that each commit or merge request that happens on one of these master branches will start the tests automatically. And the test results after all will be posted in the code repository. About test pipeline, this is how the pipeline actually looks like, that I talked about. And yeah, here you can see that this is the master branch, and this is the development branch. And if there is created new commit before that, like as I said before, there is the branch always is updated in CI system. And once developer has created several commits here, and he's not sure if the test will pass before pull request, he can go to CI system and trigger the test manually and see if the test will pass. So after that, he can merge his code, and the CI system will do the pipeline, like execute unit tests, create build, after that run the integration tests, or in some projects it could be API tests to check if the backend is okay. After that, execute acceptance tests, and if in any of these stages something fails, this test stops at this moment, post test result here, and not do anything else. If tests are okay, then the release can be made, and again the cycle will go around, and yeah, that's how the test pipeline works. This is a bit simplified test pipeline description, where you can see that after in the pipeline, if any of the stages fails, the test is stopped and the team is notified about the failure. With provided logs, screenshots, and everything else that is required. And yeah, this is how it looks like in Jenkins. There is a plugin for Jenkins to create a pipelines, where you can see which step has failed for you, and you can gain their log files, screenshots, and everything required. And when we have the system created, we are monitoring them. This is a screenshot taken from Google, from Jenkins. And basically this is how we are monitoring our jobs. Let's say this is Android project, and each field is a separate branch, and we can see what's the status of each branch. Like developer creates new branch, he executes tests, and he can see on the monitor if it's green, red, what's going on with it. Also for monitoring fabrics is a good tool to see what's going on with your system. Like one part is the crash-free users. If it goes below 90%, then you should check what's going on with the latest release. But yeah, this is actually one of the projects I'm working on, 100% crash-free users. Yeah. And yeah, that's about monitoring. And conclusions. In teams, the communication is a key. As I mentioned, whole team is involved to create a quality project. So not only QA is responsible to test the development outcome, but our team should check if all the process, how they are developing their system is working okay, if we can improve something there or not. And yeah, of course, have proper set of tests at each level that refers to the test pyramid. And be careful of acceptance test automation, because as I mentioned, the team can go really fast from creating new automation acceptance tests to fixing the breaking or flaky tests. So automation test has to be careful with this part. And yeah, testing occurs throughout the life cycle, and yeah, everyone responsible for quality, and invest in testing, because it will reduce the time to release, and also the quality will be improved. Yeah, this was really fast, I think, for me. Thank you.
All the presentation was contradiction with your slide number 3. In slide number 3 you told that testing is during all the phases,
yeah,
and after that only development and release process was involved in your presentation. Planning process, design process, all this process was out of scope in your testing latest presentation, later in your presentation.
Yeah, it's meant basically more about the process checking and looking if it's possible to improve it.
this test was in the middle of all processes, and others that only test those two.
You said you built your own device farm, stack, whatever. Let's say I want to test things on Androids and iOS and so on. Do you recommend using your cloud provider, setting up your, you said you have Post and setting up your own, but how do you compare using, like, I don't know, Source Labs, browser stack, things like these versus your own, versus your TestDevLab?
Yeah, of course, creating your own device laboratory, it will take a lot of time at the beginning, of course, to understand how to manage all with smart hubs and things like that. But the best side of that is that you can completely control your devices, you can set up whatever network conditions you want, and you can remotely access your devices at any time, and that's the plus side for using your own device laboratory. But of course, to do it, you will need a lot of devices. You will need some nodes which will control these tests, and also you will need regularly update with new devices when there comes out, and update the OS versions and so on. So yeah, there is a different pros and cons for using simulators, cloud devices, your own devices, and my opinion is that the best way is use a combination of all of these. Like for unit tests, you can use simulators. For acceptance tests, I'm using my own physical laboratory. For some other tests, you could maybe use cloud devices. So it depends. And also it depends on the budget that you have for the testing, because cloud devices always will be very expensive.
You mentioned the flaky tests, so you removed them from your scope, yeah? But from my perspective, the business always need me some valid, well, information at least, why I removed that from the scope. So the flaky test is not always actually the valid point why I removed that. From the business perspective, that means that just I was unable to automate it.
Yeah, basically that means the test you created, it's not stable. Like, there should be some principle also when creating new tests. If you create new tests, it should run 100 times with zero failure rate. And if it does, then you can implement it. But of course, there is sometimes maybe some UI change increase that the test becomes flaky. And usually, at first, what we are trying to do is to fix them. And only if nothing can be done, if we cannot fix them, then we are removing them. The other thing is that maybe we don't have time to fix them right now at this single moment, but because of this flaky test, we will not be able to merge our code. So we can maybe remove this flaky test permanently, or for some time, and when we have fixed them, then put back in our test suite, and we have still a stable test suite.
One question: if you forget about that you have to have a big zoo of different kind of devices, what is the other big difference between testing web applications and mobile applications?
Like in part of the physical devices?
No, in process like that, in general.
In general, it should be a similar process for testing. I'm referring a lot for mobile app development, but the same process can apply for desktop applications and also web applications. Yeah. So yeah, as you saw in the device lab, there was some laptops also, so we are testing desktop apps as well. Yes.
Yeah. How do you know when you have enough tests?
And not tests, like I would say that more important than having a huge coverage of the of tests is to have stable tests for the most critical parts of your project. Like once you have covered the critical parts of your project, once these tests are stable, you can go home and sleep, and developers can do their work, and you know the tests will pass. Then you can increase the amount of tests. Like don't run and try to automate the full regression in the first 2 weeks, because the tests will fail. Like let's do it slowly, starting from the critical parts, and only like working like that we can make a stable test environment.
Just the problem is when to stop making tests.
When to stop?
When you covered 80% of clicks, or when you covered 90% of clicks, because going to 100% of clicks covers automated tests, bad idea. Just where is place to stop it?
It also depends on how big is your team. Like one automation engineer, maybe he can handle to create and automate, let's say 200 tests, but if it's a large project with 1,000 tests, then you will need more automation engineers and split the tasks and the responsibilities. Because yeah, we should also take in mind the risk that can happen there.
Any more questions for Edgars? Okay, looks like that will be it. Thank you, Edgars, for your presentation.